Good morning or good afternoon, class. Today we will be finishing up talking about radicals and how to simplify them. Yesterday we talked about simplifying basic radicals, multiplying, and adding and subtracting. Well, today we're going to put all of them together, and you should have your note packet out from yesterday in front of you. And throughout this video, I'm going to ask you guys to pause it so that you can try some examples on your own. Okay? So let's first take a look. The first example is going to be 2 plus root 3 times 2 minus root 3. Okay. Remember that there's 4 parts to FOILing, or the way that I like to say it is that you have to distribute every term in one polynomial to every term in the other polynomial. So 2 times 2 is 4, plus 2 times negative root 3 is negative 2 root 3. 2 times root 3 is plus 2 root 3. And then we have minus root 9. Please make sure that you guys do show every step. Sometimes people skip steps and that's where they make mistakes. Remember that it's outside times outside, inside times inside. So this is 4. The 2 root 3 and the negative root 3 are going to cancel out. And then you have minus 3 because the square root of 9 is 3, and that equals 1. Remember that when you take the square root of a perfect square, the square root symbol is no longer there. Alright, let's take a look at number 2. We have 3 plus root 5 times 2 plus root 6. So let's multiply this out. 3 times 2 is 6, plus 3 root 6, plus 2 root 5, plus root 30. Remember that in order to add radicals, the radicand, or otherwise what's known as underneath the radical, must be exactly the same. And notice that we have root 6, root 5, and root 30, none of which can be simplified any further. Therefore, our problem is done. Okay, here's your next example. 5 minus root 6 times 3 minus root 2. Okay, I would like you to pause this video, and I want you to try the examples on your own, and once you guys have shared with each other, go ahead and play again with the video, and there will be answers ready to go. Okay, here is the example, or the answer to number 4. I'm assuming a lot of you probably got the second line, but made a mistake at the very end. Remember that you have to simplify all radicals, and root 12 can be simplified further. 12 can get broken down into 4 and 3, 2 and 2. Group what you can take out and box your leftovers. That's what stays underneath the radical. Okay, number 5 is 3 plus root 2 squared. Okay. Please do not say that this answer is 11. That means you went 3 squared is 9. Root 2 squared is 2. My answer is 11. You're going to get a big sad face if you do that. Remember that 2 squared is 2 times 2. So 3 plus root 2 squared is 3 plus root 2 times 3 plus root 2. Please don't make that mistake of just trying to square individual terms. So let's multiply this out. That gives me 9 plus 3 root 2 plus 3 root 2 plus root 4. Once again, please show all of your work so that you don't make minor mistakes. So this is 9 plus 6 root 2 plus 2. So my final answer is 11 plus 6 root 2. Okay. Remember that the integer should always come first, and we write the radical second. Okay, as soon as I get the example up on the screen, I want you to pause again and try this example on your own. All right, go ahead and pause it. Okay, here is the answer to the you try problem. It is 7 minus 4 root 3. Please make sure that a negative times a negative gives you a positive, and then root 3 times root 3 is root 9, and the square root of 9 is 3. Okay, now we're going to move on to dividing radicals, which typically is difficult for students. A couple rules that we have to go over is you cannot have a fraction underneath a radical, and you cannot have a radical in the denominator. Okay, so a lot of these problems are going to have that, and you're going to have to simplify it, or in other words, what we call rationalize the denominator, in order to fix these rules. Okay. So let's take a look at the first example of the square root of 36 all over 81. So we currently are breaking rule number 1. We cannot have a fraction underneath the radical. So the directions say take the square root of the numerator and the square root of the denominator. Simplify each radical. If the denominator is not a perfect square, go to rule number 2. So root 36 over root 81. So we're going to take the square root of the numerator and the square root of the denominator. And lucky for us, these are both perfect squares. So this is going to give me 6 over 9. And hopefully you recognize that this can be simplified further, and that's going to be 2/3. Okay. Second example, the square root of the fraction 3 over 25. We are currently breaking rule number 1, so we're going to split this. Root 3 over root 25. Root 3 is not a perfect square, but that's okay because that's in the numerator. The only time we worry about it not being a perfect square is when it's in the denominator. So this is root 3, and then the square root of 25 is 5. Okay, I'm going to put up an example for you guys to try on your own, and then go ahead and pause the video now to try it. So you should have gotten 2 root 3 over 7. If you did root 12 over 7, you would get partial credit, but notice that root 12 can be simplified further. 12 can get broken down into 4 and 3, 2 and 2, group the 2's, box the 3, and you have 2 root 3 over 7. Okay, let's go ahead and take a look at example number 4. Example number 4 is 1 over root 2. We are not breaking rule number 1, which states you can't have a fraction underneath the radical, but we are breaking rule number 2 because you have a radical in the denominator. So what we do is what's known as rationalizing the denominator. Basically, you want to multiply by a number so that the radical cancels itself out in the denominator. So this example would be root 2. Okay, so when I multiply the denominator by root 2, that is going to cancel out the radical. This would be root 2 over root 4, and the square root of 4 is 2. Notice that I no longer have a radical in the denominator. Now, please don't cancel the 2 and the 2. The 2 on the numerator is trapped underneath the radical. That is a different numerical value than the actual number 2. Okay, let's take a look at another example. Let's say we have 28 over root 7. So we're not breaking rule number 1, but we are breaking rule number 2. We need to multiply by whatever will cancel out the radical in the denominator. In this case, it's going to be root 7 over root 7. Remember that whatever you multiply the numerator by, you must multiply the denominator by. So outside times outside, inside times inside, so you have 28 root 7 over the square root of 49. Well, the square root of 49 is just 7. So 28 root 7 over 7. Okay. Root 7 and 7 do not cancel. However, 28 and 7 do. So your final answer is 4 root 7. Okay, here is an example for you to try on your own. Go ahead and pause the video now. Okay, so your final answer should have been root 3 over 9. In order to rationalize the denominator, you multiply by root 27 over root 27, which gave you root 27 over 27. If you got that far, great, but notice that root 27 can be simplified further. 27 can get broken down into 9 and 3. 9 can get broken down into 3 and 3. You can take a pair of 3's out, box your leftovers, and you have 3 root 3. Then 3 root 3 over 27 is just root 3 over 9. All right, last example with this topic, root 48 over root 18. Now to rationalize this, a lot of you will say to multiply by radical 18, which definitely works. However, you're going to get a very large number of 48 times 18, and then you would have to break that down, which would require a lot. So instead, why don't you simplify these radicals first? Okay, when you simplify them, you should get 4 root 3 over 3 root 2, because 48 breaks down into 16 and 3, 16 breaks down into 4 and 4. You can take a pair of 4's out, and you're left with a 3. And then for 18, you have 9 and 2, 3 and 3. Okay. Now to rationalize this, you could multiply by 3 root 2, but once again, you're creating more work for yourself. So you're just going to multiply by the radicals, so root 2 over root 2. So this gives me 4 root 6 over 3 times root 4. Well, root 4 is just 2, so 3 times 2 gives me 6. And then you can reduce the 4 over 6 to 2 root 6 over 3 as your final answer. Notice that all of the examples we've done so far did not include addition or subtraction in the denominator. So what happens when there is addition or subtraction in the denominator? Well, we have to multiply by what's known as the conjugate. And please remember that this is for when there is addition or subtraction in the denominator. Okay? So the conjugate is basically the opposite operation. So if you had 2 plus root 3, the conjugate would be 2 minus root 3. If you had 1 minus root 5, the conjugate would be 1 plus root 5. Okay, it's just the opposite operation. So let's take a look at the first example. 3 plus root 5. Oh, sorry, excuse me. It's 1 over 3 minus root 5. So first you have to figure out what the conjugate is, and the conjugate's going to be 3 plus root 5. So you have to multiply both the numerator and the denominator by 3 plus root 5. Now what's nice about the numerator is that you're just multiplying it by 1. So this is 3 plus root 5. In the denominator, however, you have to remember to FOIL, or in other words, multiply it out. So this is going to be 9 plus 3 root 5 minus 3 root 5 minus root 25. So that gives me 3 plus root 5. These cancel out. 9 minus 5 will give you 4. So your final answer is 3 plus root 5 over 4. Remember that the whole point of multiplying by the conjugate is so that there's no longer a radical in the denominator. So if you go through this whole process of multiplying out and you have a radical in the denominator, you made a mistake somewhere. Either A, you didn't multiply by the right conjugate, or B, you didn't multiply correctly. Okay. Then at the end of the problem, you have to check to see if you can simplify. In other words, can you factor anything out of the numerator? Well, 3 plus root 5 cannot factor any further. Okay. Here is the example I would like you to try on your own. Please do not cancel a 2 out of every term. That 6 is trapped underneath the radical. Please pause the video now. Okay, you should have gotten the final answer to be 4 minus root 6 over 5. If you got to this step right here, you did really well. It's just that you forgot to factor out a 2 out of the numerator and then cancel the 2 and the 10 to 1 over 5. Okay. Now I know this was a lot of information in a short period of time, which is why you're given a link to this video. Please refer to it over the weekend. Okay, your homework for the weekend is worksheet 3 evens, worksheet 4 odds, and worksheet 6 number 29 and 30. Okay. Please, we don't have a lot of time next week to go over this stuff, so please come in Monday with questions and having referred to the video over the weekend. Okay, use it as a resource. You have the rest of the time to work on homework. Hope you have a wonderful and safe weekend.